Well, hi everybody. So my name is Javier de la Torre, and I'm actually talking to you today from Madrid, from Spain, and I'm very honored and thank you, to Jet for inviting me to give this talk to start this conference. I'm very excited about the entire conference. It's great that you guys, the Cloud Native Foundation, is working on this. Very much looking forward for all the talks and actually to talk to a lot of you. So. Jed invited me to talk here because probably some of the recent kind of work that also we've been doing around kind of this concept of breaking the GIS data silo. So I want to kind of I want to start this conference with the perspective of why, in a way, everything that we're going to be talking in this conference matters, right? And why we are in a very important point in the industry, and why cloud native, geospatial cloud native, is actually called like the foundation that is pushing this revolution that is happening in our industry. So I hope that comes as a good kind of like a start for the conference. Now, a little bit of intro about me. And so I'm the founder of Carto, one of the leading spatial analytics platforms. Where we've been like now for more than 12 years. Also serve on the board of OGC. Heavily interested on standards, as you will see. I also happen to have founded, Visuality. It's a company, well, Carto, probably most of you know, but one of the leading location platforms. Visuality is a company I started before on doing analysis on spatial data for environmental purposes. And now I'm also on a foundation we call Tierra Pura, working on projects for conservation purposes, where we are also leveraging a ton of spatial analytics. So that's a little bit the background on me. Also very relevant to this community is that I also serve as the board on the OGC standard working group for GeoParquet. So working with the entire community, trying to push GeoParquet and everything around it. So we'll talk more about it later, and I think Chris Holmes also later, or some other members are actually talking about it. So now a little bit on the background, how I got here. One of the things I like the most about the geospatial community is that somehow we all come from different backgrounds. It's always one of the most fun to ask, how did you get into mapping? So my journey started actually as a scientist, working on so-called biodiversity informatics. So I used to work on what we call mobilizing biodiversity data, locations, where these specimens have been, and making analysis towards, how biodiversity it's right now, and how it will be in the future, and so on. So actually, as part of that, I was very heavily involved on the creation of standards for defining how do we define how to describe a specimen, like the fact that we've collected in a particular place, how to circle distribution maps, things like that, right? So I work a lot on these standards, and as I was doing, these slides, I realized that some of the work that we're doing back in the days, like in the areas like Darwin Core is kind of like the standard for biodiversity data. We were already packaging, in CSV files, putting in cloud storage, so we happily distribution. So that's actually my background on this. But through biodiversity, I really got into mapping, right? Everything happens somewhere, but when it comes to biodiversity, location is a very, very fundamental part. So this is one of the first maps I actually wanted to do. This is a map of all the data that we have on the Global Biodiversity Information Facility, a global database of data around biodiversity. So it's all these connected databases of biodiversity around the world. We put them together, and this is where we specimens, species have been found, right? And this map was, in my case, was one of the first maps I wanted to make. It was at the time around 400 million records, and it was already a challenge to make a map with this amount of data. And that's actually how I got into this journey, then later into really investing more in geospatial, and that's how I got so much into this, and later why we even started Carto. Another project that I worked that I'm very proud of is Global Forest Watch, looking at tracking deforestation worldwide in a in almost semi-real time, right? So that's also a representation of my interest of how I got into mapping. Now, going specific, into our topic right here. So I like to say that everything happens somewhere, right? And this is how I normally start talking about like our industry to customers or other people. And it's very often, like by telling them examples, right? If you think about planning where to deploy 5G antennas in case you're a telco, you're doing a spatial analysis. If you're calculating driver risk based on profiles, like based on car telemetry, you're also doing a spatial analysis. Or if you're doing market analysis, figuring out where to open a store, like where you might have more potential customers, etc. That is also market analysis, right? That is also spatial analysis. Another example, I saw it. If you mentioned before with Global First Watch, if you're looking at, like how is, satellite imagery, if you want to detect if there's been deforestation in a specific location, you will be performing also a spatial analysis, right? And more recently, we've seen, the effects of, like flooding on places like in Florida, right after 2 hurricanes passing by. And like that's also a place where spatial analytics have a very big, profound place. And I couldn't wait, like I'm obviously a lot of, I'm from Spain, but also have a lot of colleagues in Valencia. And, the recent floodings were kind of like a great example of, how we are going to be affected by, the effects of, climate change and how the weather is changing, climate is changing, and, how we're going to have to be prepared for that. So I was just actually explaining to a few people how spatial analytics is very critical in this type of scenarios for preparedness, but also then later to act in the case of crisis like now in Valencia, where so many people has lost their lives, but also lost a lot of, like their properties, and, like where situation can be quite very challenging, right? So if you look at, like an analysis like in these cases, GIS is the fundamental, where you're going to need to connect what is on the ground with what we see, for example, in this case from drones or from satellite imagery. That type of analysis of intersecting, okay, these are the house, this is the type of people that live in there, where, like this is how the flooding has passed by. Well, you all know it's a spatial analytics. This is an example of something that we are working with. And this is drone imagery from the affected areas and calculating and mixing with other sources of data to try to prepare better for the response to this effect, right? So it's a great example of, like why spatial analytics happens, why spatial analytics is needed. And to me, this is in a way, like how I want to start. Like geospatial is always been needed, but I would say like right now, it's more needed than ever. We couldn't be working in a more relevant industry. Geospatial is going to be needed more and more, and it needs to be much more widely used. Now, that's why my case, like very excited about like this potential, to like democratize spatial analytics. I believe that more and more people we're going to need to be able to do this type of analytics, and that means that we're going to have to make it more accessible for them to be able to do it. And that's what I want to also talk about today. Now, you all know geospatial comes in multiple forms, right? In vector data, raster data, mobility data, or trajectory data, LiDAR. There's many different ways. I don't need to explain you that in here. But the issue that, we have very often is that you will expect, this type of data to live in the same ecosystem than the rest of the data. You wouldn't want to have to leverage, an external ecosystem in order to analyze your spatial data together with other data. But the reality today is that very often geospatial data is siloed. So if you want to do any this raster analysis where I'm calculating the flooding impact, with what buildings, you're likely going to need to go and move your data to a geospatial platform where you're going to do some geospatial specific analytics outside the rest of your analytics infrastructure. And that is a problem from my point of view, right? I like to say that GIS data is being siloed and doesn't work with the rest of analytics. Now, here are a few reasons why this matters a lot. So the first thing, I'm going to start at the bottom, restricted accessibility. When someone, when in order to be able to do a spatial analysis like I was showing, you need to use a different platform, or you need to call someone to do it. You're limiting a lot, how fast, something can be done, and who can perform this type of analytics. So fewer members can leverage the spatial insights when you have this silo. You have like limited integrations. So maybe you are not using all the data you can because the integration between that silo with the rest of data is just too expensive. So you only end up doing whatever is the minimum that is needed. Also, we find very often the scalability often is not on the geospatial color side. The scalability, I mean, most of the money goes in analytics and most of the money is put in other infrastructure. So you end up often, having to do a lot of this on desktop or in very poor scalable color platforms because you cannot perform them with the rest of your analytics. And finally, there's also a very big cost efficiency on this. So you just have like duplicated systems, like it's essentially as an industry, we've managed to recreate an entire analytics industry just only for geo. And that's a problem. So that's why in a way, like what Carto, we're building is this concept of democratizing spatial analytics. But the way that, like we think, like this is going to happen, that we're going to break this GIS silo, it is cloud native. And this is what I wanted to touch today. Cloud native is really bridging the gap between this spatial data and mainstream analytics. And as we've seen, that's going to be a big deal. And that's actually going to be a very big revolution that we just kind of starting to see. Now, most of you, most of the initial cloud native formats that we've been talking, things like Cox, Stack, even PM tiles. Very often I see this definition of like cloud native formats as something that just is able to leverage kind of like HTTP rates request on cloud on buckets, on cloud storage, right? So it's performance, it's cost effective, We know all the good with that, right? And that's a great kind of like type of like objectives we got in that. But there is another type of like objective. What I like to say is like focusing on bringing geo with the rest of analytics. There are kind of like things like, for example, GeoParquet, GeoArrow, Geo and Iceberg, other kind of like initiatives that are happening where cloud native means more kind of like to ensure the accessibility of the data and the convergence of that data with the rest of analytics. And you see that I put SAR there in the middle because kind of like lives in between these two worlds in a way. But I like to say that, like the best way to break the GIS data silo, from my point of view, very often is to stop creating a specific spatial formats and try to make geo where the rest of analytics happens, right? So we'll see in the case of like in Parquet, GeoParquet is just Parquet, where we're like defining how geo is handling there. So that effort of like transposing what we do on geo into the generalistic kind of formats and what is happening on the analytics world is, from my point of view, one of the biggest forces that is going to make us, break this GIS silo. It's going to kind of like open it up our industry to a much, much larger audience. So Parquet it is obviously one of the biggest drivers of this. It's a format that has existed for a long time and now is very widely used on most analytics platforms. So for that, that's why we kind of like started in this place, and that's why we started with GeoParquet. So we knew that there were, first of all, there are already a lot of products that support Parquet, and a lot of those products actually support already geo. But the way that they implement, that they added geo on Parquet was slightly different. So we were already on this situation of lack of interoperability and so on. So GeoParquet, at its simple, what we wanted to enable was just the simple fact of being able to move one data from another system and the geospatial data to be respected and treated well, right? That was the initial kind of goal of it. And I'm actually pretty excited. Like very recently, BigQuery announced final support for GeoParquet. And that's not the first product that has added GeoParquet. There's already massive support for GeoParquet in most of the geospatial industry, in all the biggest players, obviously Carto, but so is Esri, FME, like all the major players in the industry already support GeoParquet. But now we have like BigQuery, one of the biggest players in the analytics world, also supporting GeoParquet for exporting, loading, and also querying externally tables. I'll show you that in a minute. But that's a very big win. For me, it means that finally, like the geospatial data is making it to the masses, to the big analytics industry. that's a huge opportunity for us, for democratization. So I'm very happy with that. And it's only the first one. And we know, because we are working with them, there's many other major analytics platforms who are also heavily investing in adding GeoParquet support. But like now that you have like GeoParquet support on something like BigQuery, you can export like a table from BigQuery into storage bucket, right? Like in this case, and now you can open it in DuckDB. And the geo data type has been respected. You can just use it straight away. No transformations needed. It's just like one more native data type. Like say like it's data harmony, right? It's nothing specific about geo. It just works like all the rest of the data. To me, that's an incredible color achievement. We're also on GeoPandas, right? So yeah, the same color file. Now you can also use it in GeoPandas without anything specific around it. Or in Sedona, in Apache Sedona, if you're working on the Spark ecosystem. All of it, like works kind of like seamlessly, because of GeoParquet. So very, very excited about that. Now, when we started kind of like GeoParquet, we thought, yeah, Parquet was kind of like the format, right? And that was kind of like the way to start. But it's becoming more and more apparent that, as the analytics industry is evolving, the geo, again, is coming up as finally, like a primary data type. Or we like, to believe, this is now the moment to really make it happen. So, like how geo is always being kind of like an extension to, like to the databases, like PostGIS is an extension to PostgreSQL, like there was never a kind of like a specific data type. It was always kind of like extended in some way. Well, now I think finally we have the opportunity that like geo to really become a primary data type and be treated entirely as it needs to be with this next generation. So I think it's a very, very exciting moment, a very important moment also, because it means that we have to make the effort to accommodate the requirements of this broader industry to accommodate geo, right? We cannot go, with all our kind of like little things. So we have to make sure that we provide a simplified kind of like journey for for these kind of like new formats that are coming. I'd like to talk a couple of minutes, to adopt geo. So there's a few initiatives that we're going in there that I think are very, very important that you should check out. Things like GeoArrow, looking, continuing, the journey of adding geospatial support at the arrow at the low level, very, very, very important. GeoParquet, about it. The last one that I'm printing here is called GeoIceberg. It's not GeoIceberg, it's really support for geo data type on Iceberg. So if you're not familiar with Iceberg essentially builds on top of Parquet to provide a table format on top of, instead of like a file format. So if Parquet is a file format, Iceberg is a table format. The idea is that you can query these Iceberg kind of like tables, just like if it was just like a data warehouse or a database, right? So it is the next kind of generation of data sharing, interoperability, and so on. And it's coming to 3.0, and there is actually a very good opportunity that Geo will be part of that. Now, we discuss a lot of these things in our bi-weekly meetings, and it will be great if you guys can join us. Now, last bit I wanted to call touch around Iceberg, because I think it matters a lot now. It's we're in a very crucial moment. As I said, like we are hopefully, looking to have a geo support on Iceberg 3.0. A lot of people have been working very hard to make that happen, and that's a really big deal. Iceberg, as I said, is it's the right now I would say is the forefront of the formats in the analytics space. So you have like all the major players like Snowflake, BigQuery, Databricks, Google, AWS, everybody more or less committed by now, and already with functional kind of like Iceberg support, and the industry is kind of like really changing to that. This is going to be a very important shift on the industry because it allows to maintain your data separated from the engine that you use. So you might have like a dedicated geospatial engine to do a spatial analytics on your data, but it will live on the same format that the rest of your data. So that kind of like distributed computing kind of paradigm, finally making it for real, performant, and standard. So I think it's a great opportunity to tap into that massive effort that the whole analytics industry is happening by adding geo into it. And now we got fully distributed, and all these benefits that we will get from that. So for me, this is one of the biggest deals that we have to that you have to watch out for. Now, just also, we just just to mention, we're only just starting, right? So if you look at things like vector data, we got like GeoParquet, we're talking about like Geo and Iceberg. But what about raster data? There's some things around GeoSAR, but what about, there's also formats like Rasket. What about trajectory data? There's also proposals around track parquet, but there's also like H3 data, like spatial indexes. What about LiDAR? So we have, in a way, now the possibility to rethink pretty much all the way that we call think about spatial data, and rethink it within this new paradigm to open it up to a much wider audience. So I mean, I know I'm coming out of time, so I just want to leave it there. I don't think it's going to be any more exciting moment that it is to work in this industry as it is right now. And I look forward to hear and to join you in the rest of the conference. Thank you very much.